Today's lesson is on sequences and series. The definition of a sequence is an infinite sequence is a function whose domain is a set of positive integers. The function values a sub 1, a sub 2, a sub 3, so on, are the terms of the sequence. If the domain of a function consists of the first n positive integers only, then the sequence is finite. So meaning if we only went from, let's say, 1 to 100 or 1 to 35, or any number, that would be finite. Infinite, it would have to continue, keep going and going and going. Now, explicit formula is the formula for an equation to represent the nth term of the sequence. For example, find the first 5 terms of the sequence, and this would be the explicit formula. A sub n equals 2 plus negative 2 to the nth power. Okay, and n begins at 1. Is an important note because some people like to begin at 0. So here, what that means is we're going to plug in 1 for n and solve. So 2 plus negative 2 to the 1, which is negative 2. So we get 2 plus minus 2 gives us 0. There's our first term. Second term is going to be 2 plus negative 2 to the second power. So plugging that in, 2 plus negative 2 squared. And this is going to be negative 2 times negative 2 is 4. Now I keep doing this because the power is going to keep increasing, and this will allow me to do negative 2 times negative 2 right here to get this number. And when we do it again, negative 2 times 4, I'll get negative 8, right? So it'll allow us to do it a little bit quicker since you could do this without a calculator. So again, 2 plus 4 is 6. Next one, we're plugging in 3. 2 plus negative 2 to the third, which is minus 8. 2 minus 8 is negative 6. And now we're going to do 2 plus negative 2 to the fourth. Well, negative 2 times negative 8 is 16. 2 plus 16 is 18. And now we're going the other direction. The fifth term is 2 plus negative 2 to the fifth. Well, this is minus 32. And minus 32 plus 2 is minus 30. So the first 5 terms are 0, 6, negative 6, 18, negative 30 from this row right here, what we just did. Okay, doing it one more time with this one, 4n minus 5. So 4 times 1 minus 5 is minus 1. 4 minus 5 is minus 1. Then we're going to do 8 minus 5 is 3 for the second term. 12 minus 5 is 7. And you'll notice this one's a little bit nicer. It kind of looks like mx plus b, like y. In this case, the sequence equals 4 times the number minus 5. And that way we just keep jumping up by 4s. So 4 times 4 minus 5, 11. 4 times 5 minus 5, 20. And that pattern continued. So we got negative 1, 3, 7, 11, and 15. Next, find the indicated term of the sequence. So again, given this explicit formula, they want the 23rd term. So we're plugging 23 in for all n's. So 23 here, 23 here. So negative 1 to the 23 times 4 to the 24 times 23, pardon me, minus 5. So we've got 23 negatives is going to give us negative 1, right? 22 will cancel. Each pair will cancel. And this is odd numbers, so we'll have 1 left over. Times 4 times 23 is 92, minus 5 is 87, so negative 1 times 87 is negative 87 is our 23rd term. Over here, our 14th term, instead of filling it all out, we'll just plug it in. 14 plus 1 times 3 times 14 minus 2 times 14 plus 5 gives us 15 times 42 minus 2, 40 times 19 gives us 60 times 0 is 600 times 19. And how I do it in my head, times 20 minus 1 gives us 11,400. And that is our final answer there. Moving on. Recursive formula. Recursive. Re usually means to do again. So in curses, yep, this is curses. Now, but literally this is an equation that uses one or more of the previous terms to determine the next term. And it can be a little bit of a pain. If they wanted to find the 23rd term, you'd have to go for a long time. But an example of this would be a sub n plus 1, so the next term equals 3 times a sub n minus 5 times a sub n minus 1. Now this would be doubly recursive, where you have 2 previous pieces. So this would require you having been given the first 2 terms, so we could do that. For example, we'll do a couple of these. Find the first 5 terms of the sequence, and this is recursive. A sub 1 is 10, and the sequence, the recursive, is a sub k plus 1 equals 2 times a sub k minus 4. So what this means is they give us the first term. A sub 1 is 10. And now we're going to plug that 10 in here to find the second term. 2 times 10 minus 4. So 2 times 10 is 20, minus 4 is 16. Now I'm not going to plug 10 in again, but now I'm going to plug 16 in to the a sub k to find the third term, because 2 times the second term minus 4 equals the third term. 2 times the third term minus 4 equals the fourth term, right? No matter what value k is, so I plug in 2, now I put 2 in here, I get the third term, right? So 2 times 16, 32, minus 4 is 28. And I'm going to do 2 times 28, 56, minus 4 is 52. And lastly, 2 times 52, 104, minus 4 is 100. And so my first 5 terms are 10, 16, 28, 52, and 100. One more time here. Now this one is, the first term is minus 4. And the next term is negative 4 times the first term, the previous term, plus 9. So first term is minus 4. Negative 4 times negative 4 is 16. Plus 9 is 25. Now, negative 4 times 25, negative 100, plus 9 is negative 91. Negative 4 times negative 91 is 364. Plus 9 is 373. And then negative 4 times 373 is going to be 1492. Plus 9 is going to be 1482? 1483. Okay, so a little off there, but pretty close. Negative 1483. And then plugging that in, those are our final numbers. Negative 4, 25, negative 91, 373, and negative 1483. Clearly, you would do some of these larger ones just on your calculator. You don't have to do them all by hand. Calculator is pretty nice to do that, and I will show you some calculator tips, tricks, and hints later on. 7, first term is 3. Second term is 8. Usually this is a red flag that it's going to be a little harder. So this says a sub k plus 2 is 3 times a sub k plus 1 minus 4 a sub k. So meaning if we want to find the third term, we're going to plug 1 in for k here. So that means we need to do 3 times this second term, 8, minus 4 times the first term, 3. Okay, so first term 3, second term 8, and we're doing 3 times, right, showing you for the third term, we're doing 3 times this term here, the 8, minus 4 times a sub 1. My a sub 2 got deleted, sorry. So 3 times 8 minus 4 times 3. That's where the 8 came from, that's where the 3 came from. So 3 times 8 is 24, 4 times 3 is 12, 24 minus 12 is 12. Now next time, the 8's going to scoot over 1, the 12's going to take the 8th spot, and the 3 is gone. Because now 3 is 3 terms ago, and we only need, to find the next term, we need the last 2. So now we're using 8 and 12. 3 times 12, 36, minus 4 times 8. 36 minus 32 is 4. And one more, 3 times 4 minus 4 times 12. 12 scooted over, 4 came over. 12 minus 48 is minus 36. So the first 5 terms are 3, 8, 12, 4, negative 36. Moving on, there is a very popular sequence known as the Fibonacci sequence. The Fibonacci sequence is the first term, the third term equals the last 2 terms added together. So to find the next term, you just add the last 2 numbers, and it starts with 1, 1, 2. So 1 plus 1 is 2. The next term is 1 plus 2 is 3. 2 plus 3 is 5, 3 plus 5 is 8, and so on. 5 plus 8 is 13, 8 plus 13, 21, 21 plus 13, 34, 34 plus 21, 55, 55 plus 34, 89, 89 plus 55, 144, plus 89 is 233, plus 144 is 377, and so on. Might seem a little tedious to go that far. However, I believe it's going to be on a test review or quiz review. Would be, I'll just give you kind of a group of 2 of them and say, continue the Fibonacci sequence, find the next couple terms. So you do have to remember that that's how Fibonacci works. If I give you 2 or 3 terms further on, you just have to know, hey, we're adding the next 2 to find the next one. Find the explicit formula for the sequence where n starts at 1. So now we're finding the a sub n equals, right, how can we write this? So the first thing to do is see if there's a common jump we're seeing. So this one, 2, 5, 8, 11. I see a +3 pattern going on here. So typically when you see that, that's kind of like slope. So a sub n equals 3n. Now where do we start at? Now a lot of people want to say 2, but it says we start with n as 1. So what you really have to do is you have to go backwards one jump. So subtract 3 from that 2 to get 2 minus 3 is -1. And so our formula is a sub n is 3n minus 1. Now if you think that's weird, plug it in. Okay, well the first term, 3 times 1, 3, minus 1 is 2. Oh, the first term matched. Plug it again. How about the second term? 3 times 2 minus 1, 6 minus 1 is 5. And sorry for the sloppy impromptu handwriting, but 2, 5, right? So it matches, right? So we do have to go to technically term 0 and make sure it's common difference times n. We'll learn more about this when we get into arithmetic sequences, which is going to have its own lesson. Next, same idea here. We got 3, 6, 11, 18, 27. Plus 3, plus 5, plus 7. As much as adding odd numbers is nice, and yeah, it worked, how could you write that? So it's not really adding, actually. It's actually squaring, right? So take away 2 from all these numbers, and what do you get? 1, 4, 9, 16. Wait, what are those numbers? Perfect squares. 1 squared plus 2. 2 squared plus 2. 3 squared plus 2. So it's +2 to n squared. So it's kind of a trickier one, but just to throw that in there. And that will wrap up today's video. Please email me any questions you may have regarding homework or anything in lesson. Thank you.